Welcome to Astronomy Daily. I'm Anna, and I'm so glad you could join us for today's episode. We've got a jam-packed show for you, covering some really fascinating developments from across the universe, and right here on Earth, too. First up, we'll dive into the latest on space missions, including an update on the Axiom Mission 4 and that unexpected anomaly that's caused a bit of a setback for SpaceX's Starship program. Then, we'll turn our attention back in time to uncover how ancient life on Earth might have survived some truly brutal Snowball Earth periods. After that, we're zooming out to the cosmos to talk about galaxy evolution and how scientists are getting closer to understanding the very birth of galaxies similar to our Milky Way. And speaking of searching, we'll explore how the hunt for alien life and advanced civilizations is now going real time, which is super exciting. Finally, we'll tackle one of those enduring planetary mysteries: why giant planets often end up in the far reaches of their solar systems. It's a bit like a cosmic game of pinball, apparently, so stick around. It's going to be a really interesting ride. All right, let's kick things off with some news from the International Space Station, or ISS. The launch of Axiom Mission 4, which was originally set for Sunday, June 22nd, has actually been put on hold again. NASA, Axiom Space, and SpaceX are still reviewing new launch opportunities, so we'll have to wait and see when it's rescheduled. Now, why the delay? Well, NASA needs a little more time, it seems, to evaluate the ISS operations after some recent repair work on the Zvezda service module's aft segment. You see, the space station's systems are all really interconnected, so they want to make absolutely sure everything is totally ready for additional crew members. They're taking all the necessary time to review the data and make sure it's safe. The crew is currently in quarantine in Florida, but they're ready to go as soon as the station gives the green light. Meanwhile, SpaceX's Falcon 9 rocket and Dragon spacecraft are reportedly in great shape, just waiting on the launch pad at Launch Complex 39A at NASA's Kennedy Space Center. Stay tuned for updates on that. It's on. Okay, shifting gears a bit to some not-so-great news. As I reported yesterday, SpaceX experienced a pretty significant setback at their Massey's test site near Starbase, Texas. On the evening of June 18th, they were doing a routine 6-engine static fire test of Ship 36 for their Starship program, and unfortunately, there was a sudden, energetic anomaly. Just after 11 p.m. Central Daylight Time, while propellant was being loaded onto the vehicle, a pair of explosions ripped Ship 36 apart, producing a large fireball and causing significant damage to the test facility. This ship was actually slated for the 10th test flight of Starship and Super Heavy, expected very soon, which obviously won't be happening now. So what happened? Well, according to SpaceX CEO Elon Musk, initial data points to a failure of a composite overwrapped pressure vessel, or COPV, in Ship 36's nose cone. These are lightweight tanks that hold high-pressure gases. A rupture acted like a shaped charge, tearing the payload wall and header tank transfer tubes. This caused the liquid methane and oxygen to mix and instantly ignite, leading to the first explosion, the nose cone collapse. Seconds later, the rest of the propellant ignited, causing the second. Fires kept burning for several hours, indicating damage to the liquid methane farm. The good news is, thankfully, SpaceX confirmed no personnel were injured and everyone was accounted for. All media and public members were safe too, thanks to preset exclusion zones. This is a crucial point, obviously. For the Starship program, though, this is a notable setback. It's the first time SpaceX has lost a ship in ground testing since May 2020. And what's more, they've lost the ability to perform testing at Massey's for now, due to all that significant damage to their static fire test stand and the surrounding infrastructure. It means that even ships like Ship 37, which just started getting engines, can't be static fired without repairs. It's worth noting that the COPVs on Starship don't share commonality with those used on SpaceX's Falcon rockets, so this issue is isolated to the Starship program. The FAA won't be involved in the investigation since it happened during ground testing. SpaceX will conduct their own. This means we're likely looking at some significant changes and delays for the Starship program in the coming months as they assess repairs and potentially inspect other ships in their fleet. It's a tough break for sure, but as SpaceX has demonstrated in the past, they will bounce straight back. From looking at challenges in space, let's turn our attention back to Earth, and a fascinating mystery from its deep past. New research out of MIT is shedding light on how early, complex life forms, what we call eukaryotes, might have survived those extreme periods known as Snowball Earth, between 720 and 635 million years ago. Now imagine our planet completely iced over. We're talking average global temperatures of minus 50 degrees Celsius. Geologists call this the cryogenian period, and whether Earth was a hardened snowball or more of a softer slush ball is still debated. But one thing's for sure. Most of it was plunged into a deep freeze. So the big question has always been, how and where did life actually survive? Previously, ideas included patches of open ocean, deep sea hydrothermal vents, or perhaps even under ice sheets. But this new study suggests another intriguing possibility: meltwater ponds on the surface of the ice. Fatima Hussein, a graduate student at MIT, explained their interest, saying, "We see evidence for eukaryotes before and after the cryogenian in the fossil record, but we largely lack direct evidence of where they may have lived during." She added, "The great part of this mystery is we know life survived. We're just trying to understand how and where." To test this meltwater pond hypothesis, the researchers analyzed samples from modern meltwater ponds in Antarctica, specifically on the McMurdo ice shelf. These ponds, just a few feet deep and meters wide, form when trapped sediments rise to the surface, absorb sunlight, and melt the ice. The bottom of these ponds are lined with microbial mats, kind of like sticky, layered communities of cells. While we know simpler life like cyanobacteria can survive in these harsh environments, the researchers wanted to know if eukaryotes, those more complex organisms with a cell nucleus, could also weather such challenging circumstances. Using a combination of lipid analysis, specifically looking for sterols, and genetic components called ribosomal RNA, they found something pretty remarkable. They discovered a surprising diversity of eukaryotic life, including various types of algae, protists, and even microscopic animals, thriving within these microbial mats. Hussein noted that no two ponds were alike, but they all hosted diverse eukaryotic assemblages from all the major groups. This really suggests that meltwater ponds during the Snowball Earth episodes could have served as crucial above-ice oases, nurturing the eukaryotic life that eventually led to the incredible diversification of complex life we see today, including us. The study was published in the journal Nature Communications. Okay, from understanding ancient life here on Earth, let's turn our gaze even further back in time to the very early universe and the birth of galaxies. There's some really groundbreaking new research that's helping us understand how galaxies, including our own Milky Way, first came to be. We're talking about a period known as the cosmic noon, which spanned from 10 to 12 billion years ago. During this incredibly active time, star formation was happening at a rate 10 to 100 times greater than it is today. And new research has been looking deeply into a particular type of ancient galaxy called Lyman alpha emitters, or LAEs. Now, without getting too technical, Lyman alpha, or LEA, is a hydrogen line emission in the UV spectrum. Basically, when young, energetic stars form, they emit intense UV light that ionizes hydrogen gas around them. And when that hydrogen recombines, it emits this specific LEA line. So detecting it is like a really strong indicator of active star formation. LAEs are thought to be the direct progenitors of galaxies like our Milky Way. They're typically low mass and very young, only about 200 to 600 million years old, and they have the highest star formation rates among all galaxies. But there's been a bit of a puzzle surrounding them. Were they undergoing their very first intense burst of star formation, or were they older galaxies just restarting their star-forming engines after a quiet period? A new study titled Odin, Star Formation Histories Reveal Formative Starbursts, experienced by LEA-emitting galaxies at cosmic noon, led by Nicole Firestone from Rutgers University, set out to answer this. Firestone calls LAEs the most profound beacons of the high redshift universe, adding that they're fantastic probes of distant galaxy populations because they shine so brightly. The team used machine learning to examine the light from 74 LAEs detected by the 100 DCAM imaging in narrowband survey, or Odin. This allowed them to trace the star formation history of each galaxy. They identified three main archetypes: those undergoing their first burst, those with a dominant burst happening now but some past activity, and those where the dominant burst occurred in the past. The exciting finding? A strong majority, 67% of the LAEs they studied were indeed experiencing their very first major star formation burst, with at most only modest activity in their past. In fact, 95% were experiencing what the researchers called dominant bursts of star formation at the time of observation. Firestone emphasized, for the very first time, we have been able to definitively show that most LAEs are experiencing their first major starburst at the time of observation and only have very young stars. This is a big deal because if LAEs are truly the precursors to galaxies like ours, then this research has essentially unlocked a part of our own galaxy's origin story. As Eric Gowisser, also from Rutgers, put it, now we know the answer to that question is yes, when asked if we'd looked far enough back to find the starting points for galaxies like the Milky Way. It really builds on those fascinating JWST findings that showed surprisingly massive, well-structured spiral galaxies in the early universe. I mean, it's all part of this incredible story of galaxy evolution. All right, let's shift gears a little bit from the cosmic past to the future of searching for alien civilizations. Imagine scanning the night sky for signs of alien technology using the very same systems that hunt for exploding stars. That's exactly what researchers are starting to do now, transforming astronomical alert systems originally designed to catch things like supernovae into powerful tools for detecting potential technosignatures. That's the evidence of advanced civilizations beyond Earth. Every single night, the Zwicky Transient Facility, or ZTF, generates up to 1 million alerts as it monitors the sky for changing objects. These alerts flow through what are called alert brokers, which are basically sophisticated software systems that process and distribute information about anything that brightens, dims, or suddenly appears in the sky. And the upcoming Legacy Survey of Space and Time, or LSST, is going to increase this volume by an order of magnitude, creating just an unprecedented flood of astronomical data. While these systems were initially built to catch explosive events like supernovae and to track asteroids, new research by Eleanor Gallet, James Davenport, and Steve Croft is demonstrating their untapped potential for SETI, the search for extraterrestrial intelligence. Their work shows how we can totally repurpose these existing astronomical systems to search for those subtle signatures that might indicate artificial structures or technologies around distant stars. The inspiration for this approach actually comes partly from Boyajian's star, also known as Tabby's star. This star, officially KIC 8462852, really puzzled astronomers with its mysterious dimming patterns a few years back. And while natural explanations like dust clouds ultimately proved most likely in that case, the study of Boyajian's star highlighted how unusual stellar behavior could potentially indicate artificial megastructures like a Dyson sphere, which is a hypothetical construct an advanced civilization might build around its star. So this new research takes that concept even further, creating automated systems to identify what they call stellar dippers. These are stars that suddenly and dramatically dim without any obvious natural causes, like a classical stellar variability or other astrophysical phenomena. The challenge, of course, is immense. How do you filter millions of nightly alerts to find the handful that might represent something truly anomalous? The researchers developed a two-stage approach. First, they used the alert broker's built-in filtering capabilities to narrow down candidates. Then, they apply additional analysis using historical data to identify stars showing unprecedented dimming behavior. They're even deploying clever optical SETI techniques like looking for planetary transit zone geometries and using something called the SETI ellipsoid. The SETI ellipsoid is this particularly neat concept that identifies the zone in space where hypothetical alien observers would have seen Earth transit across our sun, potentially prompting them to send signals in our direction. Now, the researchers are honest about the current limitations. The SETI methods that these alert brokers can execute are still somewhat limited, but they're providing suggestions to enhance future technosignature and anomaly searches, especially in the era of the Vera C. Rubin Observatory. The existing systems weren't designed with SETI in mind, so some modifications and new approaches will definitely be needed to fully realize their potential. However, the foundation is really solid. Alert brokers already have sophisticated tools for identifying unusual astronomical events. The LASER Alert Broker, for instance, offers a watch map feature that can monitor specific regions of the sky for anomalous signals. And as the Vera C. Rubin Observatory comes online with LSST, the volume of astronomical alerts is just going to increase dramatically, which creates both huge opportunities and challenges for technosignature research. More data means better chances of catching rare, anomalous events, but it also means developing even more sophisticated filtering techniques so we don't get completely overwhelmed. This work represents a really sensible approach to SETI because it uses existing infrastructure rather than requiring dedicated alien hunting telescopes. By utilizing systems that are already scanning the entire visible sky every few nights, we're essentially getting a free ride on one of the most comprehensive surveillance networks ever pointed at the sky. And while we shouldn't expect to find alien megastructures next week, this research is definitely establishing the groundwork for a new generation of SETI that could operate continuously, scanning millions of stars for those signs that we are not alone in the universe. Okay, so we've talked about searching for life, but what about the formation of planets themselves? Let's turn our attention to one of the really big mysteries in planetary science. Why are enormous and mysterious worlds sometimes found silently looping around their stars, far beyond the orbit of known planets? Like, some drift as far as 10,000 times the distance between Earth and the Sun. For decades, astronomers really struggled to explain how these lonely giants ended up so far from the warm center of their systems. But thanks to new research out of Rice University, the mystery might finally have a solution. A new study, published in Nature Astronomy, reveals that these distant worlds aren't just cosmic flukes. They're actually the natural results of wild, early life behavior in planetary systems. During this chaotic stage, young planets collide, they bounce, and they scatter, almost like balls on a pinball machine. And sometimes, if the conditions are just right, one of these planets gets pushed to the outer limits of the system, and believe it or not, it just stays there. As Andre Isidoro, a lead author and assistant professor at Rice, put it, essentially, we're watching pinballs in a cosmic arcade. He explained that when giant planets scatter each other through gravitational interactions, some are flung really far away. But if the timing and the surrounding environment are just right, those planets don't get ejected completely. Instead, they get trapped in these extremely wide orbits. This happens while stars are still part of crowded birth clusters, which contain hundreds or even thousands of stars. The Rice team, along with collaborators, ran thousands of computer simulations of early planetary systems living in these dense clusters. Many of these virtual universes showed planets being kicked into orbits between 100 and 10,000 astronomical units from their stars. That's up to 250 times farther than Neptune. Now, usually, when planets are pushed that far, they don't survive. They just get ejected into deep space and become rogue planets, wandering the galaxy alone. But in these simulations, some actually survived. Gravitational nudges from neighboring stars in the cluster helped stabilize these extreme orbits. As Nathan Kaib, a co-author of the study, explained, when these gravitational kicks happen at just the right moment, a planet's orbit becomes decoupled from the inner planetary system. This creates a wide orbit planet that's essentially frozen in place after the cluster disperses. And get this, these findings might shed new light on one of our own solar system's most intriguing mysteries, Planet 9. This theorized world, if it exists, could be between 5 and 10 times Earth's mass and orbit somewhere between 250 and 1,000 astronomical units from the Sun. It hasn't been observed directly, but several icy bodies beyond Neptune have these strange, clustered orbits that suggest they're being pulled by something big and unseen. Planet 9 could be that something. According to the study, if the early solar system experienced two specific instability phases, one during the growth of Uranus and Neptune, and another during the later scattering among gas giants, there's up to a 40% chance that Planet 9 was actually trapped in its current location. Isidoro said, "Our simulations show that these kinds of orbits are entirely possible. The solar system might not be unique, but it could be one of the more efficient ones when it comes to trapping these wide-orbit planets." The study also provides a bit of a roadmap for future exoplanet hunters. Wide-orbit planets are super hard to detect because they're so far away and dim, but the research suggests they're more likely to appear around metal-rich stars that already have gas giants. These stars could become prime targets for deep imaging surveys, and instruments like the upcoming Vera C. Rubin Observatory will be absolutely essential. This telescope is expected to help either find Planet 9 or disprove its existence by scanning the sky in unprecedented detail. It's really fascinating to think that the chaos of early planetary systems, combined with the gravitational influence of a crowded stellar neighborhood, could be responsible for these distant, stable worlds. It really adds another piece to the complex puzzle of how planetary systems, including our own, came to be. And that wraps up another exciting episode of Astronomy Daily. It's always amazing to delve into the latest breakthroughs and mysteries of the cosmos, isn't it? From delayed space missions and unexpected incidents to the ancient secrets of life on Earth, and even the search for alien civilizations, there's just so much to explore. Thank you so much for joining me on this journey through the universe's latest happenings. If you want to catch up on all the latest space and astronomy news with our constantly updating newsfeed, or if you want to listen to all our back episodes, be sure to visit our website at astronomydaily.io. That's astronomydaily.io. And hey, don't forget to subscribe to Astronomy Daily on Apple Podcasts, Spotify, and YouTube, or wherever you get your podcasts. We'll be back tomorrow with more news from beyond our world. Until then, this is Anna signing off and reminding you to keep looking up.